Hi, in this video we're going to learn how to solve problem 1.1 in the Griffiths and Shroeter Introduction to Quantum Mechanics, 3rd edition textbook. Problem 1.1a asks us to find the expectation value of j squared and the expectation value of j. So the general form of any expectation value, x, will be x equal to 0 from x, p, and the probability of getting that x. In this case, we're going to replace x with j, and j represents age, and nj represents the number of people for that age in this histogram. So the expectation value of j will be the summation from j is equal to 0, and then we don't have to go all the way up until infinity since we know that the last value is 25. Then it'll be j and the probability of getting that age. Now we can write the full summation out. So we'll do j is equal to 14, and the probability of getting 14 is 1 over 14 since there's 14 total samples. And then we'll do the same thing for the rest. This will end up being equal to 21. So if we want to find the expectation value of j squared, we just do 21 squared, which is 441. And then now to get the expectation value of j squared, what we need to do is use the same summation as before, but now instead of j, it's j squared and the probability of getting that j. So I just copied and pasted this line from above, and all we need to change from this is to add a square up here. So we add a square on all of these numbers. And instead of it being 21, it is now 459.6. So question 1.1a is done. We'll go to question 1.1b. For problem 1.1b, it wants us to find delta j, which is equal to that value j minus the expectation value of j. And it wants us to use this to find the expectation value, and the expectation value squared is equal to the summation of j from 0 to 25 of the change in j squared and the probability of getting that j. Now we have to compute all of the delta j's. So it'll be delta j of 14 is equal to 14 minus 21. Delta j of 15 is equal to 15 minus 21. And we'll do that for the rest. Now that we have all the delta j's, we could just plug it into this equation here. So it will be sigma squared is equal to -7 squared, and the probability of getting 14 is just 1 over 14 plus -6 squared, and the probability of getting this will be 1 over 14 this will be 3 over 14, and we'll do the rest. And ultimately, this comes down to 18.571. And in order to get just sigma, we have to take the square root, and the square root of that will be 4.309. Okay, so we're done with question 1.1b. Question 1.1c asks us to use the alternate form of the standard deviation equation, which is the sigma is equal to the expectation value of j squared minus the square of the expectation value. And we've already computed these values in 1.1a, and what we got for j squared is 459.6, and then the expectation value squared is 441. And this will come out to 4.309. So we see that if we use this form of the standard deviation, we'll still get the same result as if we use this form of the standard deviation. So 1.1b and 1.1c just verifies that both of these forms are equivalent to each other. In this problem, the standard deviation of the ages are 4.309. Okay, I hope this video helps. Feel free to leave any questions in the comments. Thank you.